Hey guys, so we are starting the day 3 video today, and today we're going to be talking about naming molecular compounds using the stock system. Okay, so last week we talked about using the prefix system to name molecular compounds. So we talked about mono means 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6, hepta is 7, nona is 9, and deca is 10, right? So when we were using them in naming the compounds, we talked about how phosphorus trichloride. This means that we have 1 phosphorus and 3 chlorines. Phosphorus pentachloride means that there's 5 chlorines and 1 phosphorus. Dinitrogen monoxide, 2 nitrogens, 1 oxide. So depending on the prefix that you had before the compound that we're talking about, the element that we're talking about, we know how many elements there are. Now, in the stock system, we don't use prefixes, we use Roman numerals instead. So, these Roman numerals actually don't indicate charges like what we were talking about back when we were in like iron 2 and iron 3 and transition metals. This Roman numeral indicates the oxidation number of this atom right here, so of the phosphorus. So this phosphorus has an oxidation number of 3. This phosphorus has an oxidation number of 5, and so on, right? So, in order to actually find this, we have to actually go and look for the oxidation number before we can assign a name. So you guys remember the stock system we have used before when we talked about the transition metals, like for example, iron can have a charge of +2 or +3, and the reason we assign a Roman numeral to it is so that people who come and look at this compound that we're giving them can know what the charge on iron is. Same thing in this situation, except here this number is assigning an oxidation number so that a person who looks at this can know that phosphorus has an oxidation number of 3 in this compound and 5 in this compound, and nitrogen has an oxidation number of 1 in this compound and 2 in this compound. So now let's go ahead and try some examples of this. So just remember, when we're naming using the stock system, the first thing we need to do, this nitrogen right here, so if I had a compound like NO, okay, this is a compound, this is not just a statement. N is just going to get its regular name, nitrogen. O is not going to get its regular name. We're going to change it to oxide, so it's not going to be oxygen. We're going to erase the end of the name and add IDE instead, just like what we were doing before. So this is going to be nitrogen oxide, and between them there's going to be this 2. This 2 is the oxidation number of nitrogen. So let's go ahead and try to prove that. So I can see here that this whole thing has an overall charge of 0. So I know that it's N plus O equal to 0, right? So now I know that when oxygens are bound to other nonmetals, it's not bound to fluorine, it's not in the form of a peroxide, it has an oxidation number of -2. So I know that this is N minus 2 equals 0. So if I change this to that side, I have to add a +2 and a +2 here. So I get N, these two cancel, equals to +2. So I now know that my nitrogen has an oxidation number of 2, just like what we found here. So I know that it's nitrogen 2 oxide. Perfect. Now let's try another example. Here we go, CI4. Now, in this case, what you need to do is you need to go to the second rule that we talked about. It's way earlier in the slides. Remember, you're always going to be referring back to those rules, and you're going to go find the oxidation number of the one with the highest electronegativity. So in this case, it's going to be iodine, okay? Now, iodine, when we are looking at a compound, the atom in that compound that has the highest electronegativity is going to take on the oxidation number of just its regular charge. So iodine usually would have a charge of -1. If it was to form an ionic compound, it would have a charge of -1, okay? Carbon is the one that can have more than one oxidation state. Iodine can too, but since it has a higher electronegativity, we're going to just assign it its regular charge. Okay? So now we are looking for this guy, and our overall charge of Ci4 is equal to 0 because I don't see any charges written there. This is right here for iodine. It's not the overall charge of the compound. So let's go ahead here and try to figure this out. C plus I4 is equal to 0. So C plus 4 times -1 equals to 0. And this is because I have 4 iodine atoms in my compound, right? So now, right here, carbon minus 4 equals 0. And if I do plus 4 on this side and plus 4 on this side, these two will cancel out, and I'll have a 4 there. So carbon has a charge of positive 4 in this case. Remember, in other compounds, carbon will have different charges. Just like what we talked about yesterday, carbon can have charges of -4, +4, and +2. So this is one of those ones that is kind of a mystery, right? So we've got to actually go ahead and find it. And now let's assign its name. Remember, we've got to follow these rules. So the name of the first one, followed by its oxidation number, followed by the name of the second atom with an "ide" at the end. So this one is going to be carbon 4 iodide, right? So carbon 4 iodide, and this 4 is indicating the charge of the carbon. All right, so let's try another example. H2O. As you guys know, water is basically H2O's nickname. As in, when we're talking about naming these compounds, you can't just say it's water. You have to actually give it its specific name because that's what the lesson is asking you to do, okay? All right, so H2O. Let's go ahead and try to figure this out. So I know that I have a specific rule about oxygen in compounds. Oxygen in a compound like this would have a charge of -2. It's not bound to fluorines. It's not in the form of a peroxide. So we just assigned it a charge of -2, okay? So now I can see that my overall charge on this compound is 0. So what we're going to do is H2 plus O equals to 0. So this means 2 times H. H is unknown, right? That's what we're trying to find. Plus -2 equals 0. So we're going to get 2 times H minus 2 equals to 0. So I want to move this to that side. I obviously have to change its sign or do this. +2, +2, these two cancel. So I got 2 times hydrogen equals to +2. Okay, now we have not perfectly isolated this yet because there's still a 2 on this side. We want to get hydrogen by itself. Some of you probably already knew how to do this, so if you divide each side by 2, you can cancel these 2 out and you can get hydrogen by itself. So this would equal to +1, because obviously 2 divided by 2, or any number divided by itself, is equal to 1. So now I know that I have hydrogen with an oxidation number of +1 with an oxygen. So my name, if I'm following these rules, is going to be hydrogen 1 oxide. So hydrogen 1 in Roman numerals, oxide. That's just another fancy way to write water, okay? So this is the basic thing that you've got to be able to follow. You have to be able to find the oxidation number of the compound and then give it a name, all right? So let's go ahead and just name a few of these ones that we talked about from before. So let's say this one. This one, sulfur has an oxidation number of +4, which means we're going to get sulfur 4 oxide. And here we're going to get sulfur 6 oxide, right? No need to indicate how many oxygens there are, it's just given. All right, guys, so we're done with day 3. If you're confused, go back and watch the video again. Review how to find oxidation numbers. Make sure that you understand the concept really well. And tomorrow you're going to be doing a quiz on the entire lesson. So day 1, day 2, and day 3. All right, guys, good luck.